Welcome to the Global Voices of AI, Culture, Trust, and the Future of Language Models, a special episode from AI Frontiers. Today, we explore the latest breakthroughs in computational linguistics, focusing on how AI interprets culture and language, with insights from 37 recent research papers. We will address themes of trust, efficiency, and fairness in language models, and spotlight the influential study, The American Ghost in the Machine, by Luther and colleagues. Join us as we consider what happens when AI becomes the voice for the world. Does AI really speak your language? Surprisingly, even the world's most advanced language models tend to think like Americans, regardless of where they are built. Imagine asking a chatbot in Paris about local customs, only to receive responses that sound distinctly Silicon Valley. This phenomenon highlights how deeply the data and design of AI shape its worldview. As language models increasingly inform our decisions in health, law, and cross-cultural exchanges, it is vital to question how closely AI reflects the voice of your own culture and whether it can truly be trusted to understand your unique context. To set the stage, language models have become integral to daily technologies, powering search engines, virtual assistants, and translation tools. In December 2025, 37 pivotal research papers were published, each contributing to the effort to make AI not only more intelligent, but also fairer and more trustworthy. This episode brings you stories, insights, and big ideas from this body of research, revealing how language technology is quietly transforming the way we live and interact. Stay with us to see how the latest advancements are shaping the future. Computational linguistics serves as the bridge between human meaning and machine logic, acting as a universal translator not only between languages, but also between the complexity of human expression and the precision of computer code. Think of it as a conductor harmonizing an orchestra, where grammar, context, emotion, and intent work in concert. This field underpins features like autocomplete, translation, and voice assistance, and forms the backbone of innovation for advanced language models, such as GPT-4. At its core, computational linguistics enables machines to not just process, but to understand language. Our first theme is trust and cultural alignment, as examined by Luther and colleagues. Their research revealed that language models often echo a United States-centric worldview, regardless of where they are developed or deployed. This effect is likened to parrots trained worldwide, all speaking with a New York accent. Such cultural alignment has significant implications, particularly in sensitive areas like law, healthcare, and global advice. Trust in AI depends on understanding and addressing these embedded biases. The concept of cultural prompting, guiding models to simulate specific cultures, is introduced as a technical strategy to mitigate these biases. The second theme centers on efficiency and scaling, as explored by Gelberg, Yuan, and their teams. Their work focuses on reducing the computational weight of language models and increasing processing speed, akin to marathon runners shedding excess weight to sprint. By removing elements such as positional embeddings, models can extend their memory and process longer texts while using fewer resources. Positional embeddings, which help models track word order, are a technical component under review, with research showing that their removal can lead to more efficient and scalable AI systems. Moving to the third theme, researchers have addressed issues of hallucinations, adaptability, and interpretability in language models. Dizeroth and collaborators developed an AI courtroom that requires evidence for every answer, reducing unsupported claims. Shivaranu and Hashaloni worked on adapting models for rare languages and specialized domains, enhancing versatility. Tools introduced by Rauba and Zhang allow for insight into the model's decision-making process. Akin to a magician revealing the method behind a trick, models that can abstain when uncertain further build user trust, marking progress toward more reliable AI. Key findings from the research can be illustrated through several mini-stories. Luther and colleagues identified an American ghost haunting global AI systems, with models reflecting U.S. cultural values. Gelberg's team demonstrated that removing a model layer could double its memory capabilities. Dizeroth's approach of requiring evidence for answers significantly reduced AI hallucinations. Mello and collaborators found that even small semantically chosen data tweaks could dramatically affect machine translation quality. Sue and team introduced a method for AI to log and learn from its mistakes without the need for retraining, allowing for continuous improvement. Focusing on the featured paper, The American Ghost in the Machine by Luther and Associates, 8 leading language models from around the world were tested for cultural bias. Using frameworks such as the VSM-13 International Survey and Hofstede's Cultural Dimensions, the researchers assessed how each model aligned with values like individualism, respect for authority, and uncertainty avoidance. The findings revealed a pronounced U.S. tilt, even in models developed in China. Unless directed otherwise, these models consistently echoed U.S. values, raising important questions about the role of AI as global digital diplomats. The concept of cultural prompting was further examined to determine if language models can be guided to reflect local perspectives. Luther's team used this technique to prompt models to respond as if from cultures such as China, France, India, Iran, Japan, or the United States. While the models could mimic some cultures, particularly European or Indian, they struggled to convincingly represent Japanese or Chinese viewpoints. This limitation may be attributed to data imbalance or constraints in model architecture. The analogy of an orchestra with brass instruments overpowering strings illustrates how dominant cultures can overshadow others, highlighting the challenges in achieving true global representation within AI. The implications of this research are significant and constitute a call to action. Dominant data sources and architectures shape the worldview of AI, and achieving diversity is not as simple as adding more data or issuing targeted prompts. Developers are encouraged to pursue smarter data selection, advanced architectures, and rigorous evaluation methods. Cultural bias remains persistent and requires systemic change to be addressed effectively. True multilingual and multicultural AI will depend on ongoing vigilance and global collaboration, as emphasized by Luther and colleagues. Looking ahead, computational linguistics can be envisioned as a growing city with new neighborhoods dedicated to trust, diversity, and efficiency. Researchers act as urban planners, designing smarter connections between different modalities and cultural contexts. Emerging directions include customizable cultural modules, enabling models to better reflect local voices, and interactive, explainable AI systems that function as public squares for transparent dialogue. The integration of speech, text, and images will further broaden the scope, allowing machines to develop a deeper, more nuanced understanding of human communication. In summary, language models are more than technical achievements. They mirror our cultures, histories, and intentions, as highlighted by Luther and others. Recent advances in trust, efficiency, adaptability, and fairness, exemplified by the work of Gelberg, Dizeroth, and their teams, are shaping not only the future of technology, but also the way people interact with one another. Listeners are encouraged to explore the research, share their insights, and participate in the evolving dialogue. Teaching machines our stories is a collective journey, requiring input and reflection from diverse voices worldwide. This presentation was synthesized using GPT, specifically OpenAI's model GPT 4.1, text-to-speech technology from OpenAI, and visuals generated with Google Image Tools supported the creation of this episode. All content has been reviewed by a human expert to ensure clarity and accuracy, though some minor oversights may remain. For a comprehensive understanding, please consult the full list of references. AI Frontiers is committed to transparency and continual improvement in all aspects of content delivery. If you enjoyed this deep dive, consider subscribing to AI Frontiers for weekly insights into the latest research on language, vision, and reasoning in artificial intelligence. Stay informed about breakthroughs and join a global community dedicated to shaping the future of AI. Comment below to let us know what questions you want answered next. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.